Hello everyone, this is Santosh from Tyagarajar College of Engineering, and today I am going to discuss about multi-terminal HVDC system. Before getting into multi-terminal HVDC system, I would like to share some basics of HVDC system. HVDC system. HVDC stands for High Voltage DC Transmission. HVDC is a system which is used to transmit bulk DC power to long distance. They are less expensive than AC transmission in terms of long distance, because in terms of in long distance AC transmission will have more losses. If we transmit AC power to long distance, the losses will be very high, so that it 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 is inefficient in terms of long distance. But in if we consider HVDC system in long distance, it is very efficient and it is very effective too, because these in HVDC transmission the losses are very less, and also they have much less losses than AC system. So for long distance, HVDC system are preferred than HVAC system. The types in terms of terminals, there are three types, which is back to back HVDC system, point to point HVDC system, multi terminal HVDC system. Let us discuss one by one. Back to back HVDC system. The HVDC system which transfers energy between the AC buses at the same location is called back to back system or an HVDC coupling system. It is nothing but both the sending and both the rectifier station and the inverter station are in the same station, so that it just acts as an intermediate or a couple between two AC buses. In back-to-back HVDC station, the converters and rectifiers are installed in same station. It has no transmission lines. It only acts as a coupling system to two AC buses. That's what the back-to-back HVDC system does. And two terminal HVDC system. In two terminal HVDC system, the terminals with two terminals and one HVDC transmission line is called two terminal HVDC system, or it is also called as point to point system. Here we can see that here is a uh, rectifier station, as well as here is a inverter station. In between there is a transmission line. Sorry. In between in between there is a transmission line, which will be in very long distance. In this type of system, there will not be any intermediate connection or tapping in between the transmission lines. There is a it's like end to end, from the sending end to the receiving end. Sending end is a rectifier station and the receiving end is a inverter station. And multi-terminal HVDC system. In this type of system, which has more than two converter stations. From the diagram, we can see that there are four converter stations: R1, rectifier 1, rectifier 2, inverter 1, inverter 2. There are four stations available here. This type of system is called as multi-terminal HVDC system. In short terms, it is called as MTDC system, which is multi-terminal DC system. It is too complex than the normal point-to-point HVDC system, because the control system is more elaborate, because it should control more than two converting stations. So their tappings will be more, the parallel connections will be more, so that we communication between telecommunication between those tappings and stations will be much required one. It is more complex system too. It makes the system more complex. This is why multi-terminal HVDC system is more complex. In multi-terminal HVDC system, there are two possible schemes, which are constant voltage parallel configuration and constant current series configuration. In constant voltage parallel configuration, we can broadly classify into radial DC network and mesh network. We will discuss it one by one. Here the radial DC network. A radial DC system is one which disconnection of one single segment of transmission would result in interruption of power from one or more converter stations. From there, here we can see that if the power, if in any case, in worst cases, If any damage occur here and the power is here it is disconnected, the power, these two stations these two stations also these two stations also will be affected due to this disconnection. This type of system is called as radial DC network. And mesh MTDC network. In mesh system, removal of one link would not result in disruption provided the remaining links are capable of carrying the required power when the load increased. If for example, if in mesh system, if this line is disconnected, there is a possibility to um, have a whole closed circuit, or else not a closed circuit. There is a possibility to give supply to these stations without this line, in case provided that it is the links are capable of carrying the required power when the load increased. That's one limitation here. We can conclude that mesh system can be more reliable than radial system, because even when in worst cases if there is any disconnection appeared, we can and manage the system without any interruption until the link gets connected. This is what the advantage of mesh MTDC system. And constant current series configuration system. In constant current series configuration system, it is this is the extension of two terminal systems, which is a series connected system. For example, without this station converter station, it would look like an two terminal two terminal HVDC system. If we connect it in the series, intermediate series, then it would look like a constant current series configuration system, because it is an extension of two terminal system, which is a series connected system. In the MTDC series system, a central control would be required to adjust the current in response to changing the load condition. Due to changing the load condition, the current there should be a central control system which should require to adjust the current in response of changing load conditions. But these type of series connections configurations are not mostly preferred. Everyone mostly they will prefer to go with the parallel configuration. Application of MTDC system. Bulk power transmission from several remote generating stations to load centers by adding tappings. In point to point system, the main disadvantage is what is that it transfers from receiving end, sending end to receiving end. In between there won't be any intermediate taps. But if there is in between, if there is any requirement from the load center, we cannot get any tapping and get power from that for the load center. But in terms of MTDC system, it is possible to extend the system by adding more tappings and getting power for the load centers. This is what here said. Bulk power transmission from several remote generating stations to several load centers, several in the sense many load centers, by adding tappings. Each generating plant is connected directly to a rectifier station, thereby dispensing the AC collector system. Similarly, a converter station at each load center eliminates the need to build additional AC or DC lines for flexible energy exchange. These are the application of MTDC system. And here it is a comparison between series MTDC and parallel MTDC. First thing is, high speed reversal of power is possible without mechanical switching. In series, there is a reversal of power is can be done in high speed without any mechanical switching, but it is not possible in parallel MTDC system. Insulation coordination is a problem in series system as a voltage along the line varies. Due to it is a series, the voltage along the lines will vary. So that the insulation coordination is a problem, very big problem in series MTDC. But in parallel MTDC, it won't be a huge problem. For small power rating of the tab, series may be cheaper even though valves have to be insulated for full voltage to ground. In terms of smaller power ratings, series MTDC are very cheaper. The parallel connection has the advantage of Staged development in the converter station by adding parallel converters as a power requirement increases. If the power requirement increases, we can add the parallel converters as much as we can. This is the main advantage of parallel MTDC system. Okay, let us discuss about the MTDC system in India. Power Grid had installed plus 800 kilovolt, which is ultra high voltage, and 6000 megawatt ultra high voltage DC system, which is of course, which is a MTDC system of approximate length of 1728 kilometers from northeastern region to Agra. There are inverter stations are Agra, and rectifier stations are Biswanath, Chariali, Alipurduar, and rectifier stations each handles 3000 megawatt, and converter stations at Agra handles 6000 megawatt. And first MTDC in India, it is the first MTDC in India and world's first UH ultra high voltage DC MTDC system. There is no ultra high voltage MTDC system before this, and the first MTDC system around the world is from Italy. Okay, here it is a schematic diagram of the India's ultra high voltage MTDC system. Here are the both the Biswanath and Alipurduar are the uh, rectifier stations, and Agra, here Agra is a converter station. The Biswanath and both rectifier stations handles 400 kilowatt and 400 kilowatt, and it's a 3000 megawatt capacity, which has a 3000 megawatt capacity. And in case of Agra, here it is a 800 kilowatt capacity and 6000 megawatt capacity, and it also has its converter stations in it. This is the main schematic diagram of the HVDC, ultra high voltage HVDC system in India, which is from the northeastern part of India to Agra. And the salient features of uh, MTDC system, which is in India. It is a first 800 kilowatt MTDC system in the world, and first 12 pulse 800 kilowatt terminal of the world, first multi-terminal with continuous 33% overload future. While considering this, this will be the highest capacity of HVDC project of the world. These are the main salient features of our India's HVDC system, which is a MTDC, ultra high voltage DC transmission system, which is from northeastern part of India to Agra. Okay, this is about the multi-terminal HVDC systems, and thanks for the opportunity. Thank you.